What if I told you one of the biggest unsolved mysteries in mathematics can be explained with nothing more than adding, dividing, and multiplying? This is the Collatz Conjecture, also called the 3n+1 problem, and it's so simple that anyone can try it right now. The rules are easy. Take any number. If it's even, divide it by 2. If it's odd, multiply it by 3 and add 1. Keep repeating, and you'll see the numbers bounce around in a strange dance until, almost like magic, they always seem to fall into the same loop: 4, 2, 1. Every number we've ever tested eventually collapses into this cycle. But here's the catch: nobody on Earth can prove that it will always work. Imagine a flowchart where you start with any number. If it's even, you divide it by 2. If it's odd, you multiply it by 3 and add 1, then follow the arrows back to repeat. It looks simple, almost like a game, but behind that simplicity lies one of the greatest unsolved puzzles in mathematics. Let's try an example together. Start with the number 6. It's even, so divide by 2, you get 3. Now 3 is odd, so multiply by 3 and add 1, that's 10. Keep going, 10 becomes 5, then 16, then 8, then 4, 2, 1. No matter where you begin, the numbers always seem to fall into that same repeating cycle: 4, 2, 1. You can try 7, or 19, or even a giant number with millions of digits. Computers have tested trillions of numbers, and not a single one has ever escaped this loop. But here's the twist: mathematicians can't prove why. It's one of those problems that looks like a riddle for kids but hides a monster underneath. Some of the brightest mathematicians alive have tried to solve it. In fact, legendary mathematician Paul Erdos once said, "Mathematics is not yet ready for such problems." Think about that, something so simple, yet so deep, that even the greatest minds are stumped. Picture an animation showing different starting numbers: 6, 7, 19, all bouncing up and down unpredictably before falling into the same steady rhythm: 4, 2, 1. It's like chaos turning into order right before your eyes. You might be asking, why do mathematicians care so much about this? Well, it's not just about the numbers, it's about patterns, logic, and the limits of human knowledge. Problems like the Collatz Conjecture test the foundations of mathematics. If we can't solve something so simple, what does that say about the bigger mysteries of the universe? Some even wonder if the Collatz problem connects to deeper areas like chaos theory, randomness, or the structure of algorithms themselves. Imagine a graph showing the Collatz paths for numbers 1 through 20, all chaotic at first, but eventually crashing down to that same small repeating cycle. So here we are, faced with a puzzle so easy a child can play with it, yet so difficult that the world's top mathematicians are still scratching their heads. The Collatz Conjecture reminds us that in math, even the simplest rules can lead to infinite complexity. Will it ever be solved? Maybe in our lifetime, maybe never. But until then, every time you try it out with a new number, you're stepping into the same mystery that has puzzled the world for decades. This is the first episode in our series on unsolved math problems. If you enjoyed this, make sure to subscribe so you don't miss next week's mystery. Who knows, the solution might one day come from someone just like you.